Hey guys, here's the spiral review for spiral 15. You might notice that all of the problems that are not videoed are done out so that you can see the answers for those if you're struggling. But only basically the first problem of each type is going to be videoed with me kind of talking through that process. All right. First off, I'm going to see, okay, to get from x to 3x cubed, we need 3x squared, and I'm going to distribute that down to get 3x cubed minus 6x squared. Then I subtract. Get 0. Negative 4 minus negative 6, we got to be really careful, it's going to be positive 2x squared. All right. I'm also going to bring down the 5x at this point before I repeat the process. To get from x to 2x squared is going to be plus 2x, and distribute that. 2x squared minus 4x. We get 0, and we get 9x. Bring down the minus 6. And then finally, x to get to 9x is going to be a plus 9. And when I distribute, we get 9x minus 18. When I subtract, we get 0 and 12. 12 is my remainder, so that's going to be 12 over x minus 2 up top. All right, setting this up synthetically to check our work is going to be a positive 2 out front, 3, negative 4, 5, and negative 6 on the inside. Bringing the 3 down, 2 times 3 is going to be 6. Adding, we get 2. 2 times 2 is going to be 4. 5 plus 4 is going to be 9. And 2 times 9 is going to be 18. And then we get 12 at the end. My remainders are the same in both cases, so I know that that is done. If you only did the synthetic part, you absolutely must convert this to a polynomial. And working backwards, that's the remainder, 12 over x minus 2. Then we got the number, which is going to be 9. Then we got the x, 2x, and then we got the x squared, which is 3x squared. If we kept going, it would be x to the third and so forth, but here we only go up to x squared. And then finally, these two questions really ask the same thing in a different way. And the big idea here is that we have a remainder that's not equal to 0. So in both cases, the answer is going to be no. And you might say that the remainder is 12, not 0, or even just the remainder is 12. Interestingly, that would mean that f of 2 would be 12, because the remainder is going to be the same value if you plug that into the function. Next up, we got to do some identifying of rational roots, good guesses, and then use some division. I've made these so that the leading coefficient is 1, so you don't have to worry about any fractions, and it makes dividing a little bit easier as well. Okay, so identifying all possible rational roots, I look at my constant, and then I find all of the different factors of this. We got plus and minus 1, and we're going to have plus and minus 11. And that's it. 11 is a prime number. Those are the only numbers that multiply to get to 11. That also makes it kind of nice for us in terms of trying to find factors. We only have 4 things to guess. I might start with like x minus 1, which really means a root of 1. And that's going to be, I can't really see based on my screen. All right, so we got 1, negative 9, negative 21, and negative 11. Let's see what happens. Bring the first one down. We got 1. 1 times 1 is 1. We got negative 8. And 1 times negative 8 is negative 8. Negative 29. Negative 29. And that's definitely not 0. Okay, so 1 didn't work. I'm going to put a cross through the plus 1. Let's try x plus 1, which is putting a minus 1 out here. Same thing, 1, negative 9, negative 21, and negative 11. Bring the 1 down, we got minus 1. That's minus 10. Well, negative 1 times negative 10 is positive 10. Minus 11 times negative 1 is positive 11. We get 0. That's what we're looking for. Okay. So that's going to be x squared minus 10x minus 11. And that's going to factor into x minus 11 and x plus 1. Just as a side note, if you do not want to factor, what you can do is take what you have here and keep going with the synthetic division, although you don't have to do this. What I mean by that, I'm going to do this down here, is that you could do this as 1, negative 10, and negative 11. And by the way, I'm just going to put my x plus 1 here. And I don't know, maybe I take this and I try like 11 or something. So if we go 11, that would be x minus 11 here. So then we go down, so we got 1, 11, 1, 11, and 0. That's kind of nice. So that would be my second factor. And my third factor would be this thing, which is x plus 1. Those are the same two things that we got here, but without factoring, we used synthetic division instead. It doesn't really matter which way you do it. Factoring is a little bit faster, especially if you have lots of roots to try, but synthetic division will work just fine. All right, last part, identifying the zeros. Each one is going to come from a factor. We do the opposites. And by the way, I like how oh, those are the same on both sides. Okay, never mind. I'm just talking to myself. It's cool. So we got negative 1, we got 11, and then we got negative 1, which is a double root for that. All right, next up we've got some rational functions. First part we got to do is be able to read and interpret a graph. We got to look at the end behavior and the behavior around the vertical asymptote. As x approaches negative infinity, that's talking about going to the left. So that's looking at what's happening on the left side of this graph. This kind of reminds me of the one you guys just had on your spiral, where you can't actually see what this value is. So this is 20. 1, 2, 3. So there are 4 steps. Each of these is going to be 5. I'm going to pretend this is 2. And let's just call this 2 going to the left. This was a mistake in terms of copying the numbers. You should be able to see that, but you can't really see that going on here. But so that's okay. So in looking at this, that is coming down to a height of 2 going to the left. And if I look at the next one going to the right side, it's coming up to a height of 2 as well. If you have a horizontal asymptote, both of the end behavior, basically what these are called, are limits, are going to be the same value. All right, as x approaches negative 2 from the right, so I'm talking about this asymptote now. As I go here from the right, we're going up. And if we're going up, this is positive infinity. And then finally, as x approaches negative 2 from the left, that negative means from the left side. Start on the left, and I approach the asymptote, we're going up. This is going to be a positive infinity as well. Next up, we're going to have to do some finding characteristics and graphing, and then sketch the graph. I'm going to go piece by piece here, starting with the vertical asymptote, which is always the denominator is equal to 0, and here we get x is equal to 1. Let's see if I can use, there we go. Continuing my line. All right, horizontal asymptote, that's going to be based on the ratio of leading coefficients. If we plug in really big numbers, we get 3x over 1x, which is going to be 3. So we're talking about a height of 3. I'm going to label this y equals 3, and I'll label the other one x equals 1, just so I know that they're there. Next up, we've got the X-Intercept. And for the x-intercept, we're talking about setting y equal to 0. And the shortcut here is dealing with just the numerator. So 3x plus 9 is equal to 0. That's going to give me x is equal to negative 3. And then we got the y-intercept. That's when x is equal to 0. And when we do that, we were going to have 0 plus 9 over 0 minus 1, which is negative 9. Finally, my graph, the left side of this is easier because I've got the 2 points here. I've got to connect those points and go towards my asymptotes. The right side is going to be the opposite corner. Next up, we've got some rational expressions. The first thing we got to do is factor and then identify some excluded values, and then finally do some reducing if we can. Both the top and the bottom of this are factorable. For the top, if I do a times c is going to be 7, which means we got a b of negative 8. Looking for things that add up to negative 8, multiply to 7, that's going to be negative 7, negative 1. Since we have a 1 out front, we can use the shortcut, x minus 7 and x minus 1. On the bottom, we're going to have a times c is going to be negative 1, b is going to be 0 because there's no x term. Things that multiply to negative 1 and add up to 0 are going to be negative 1 and positive 1. You might also notice that this is the difference of two squares, and that's going to be the square root of x squared, which is x, and then the square root of 1 is 1. We're going to do a plus 1 and a minus 1. Same two values that we got here. Next up, we got our excluded values. Whatever would make the denominator equal to 0, so in this case, x plus 1 cannot equal 0, which means that x cannot equal negative 1, and x minus 1 cannot equal 0, which means that x cannot equal positive 1. Big idea here is that we only look for excluded values in the denominator. We don't care about the numerator at all. These are just places that we're dividing by 0. And then finally, I'm going to cancel out my x minus 1s, leaving me with the final answer of x minus 7 over x plus 1. Moving on to one with some division, we're going to start this off the same way. I've set these up so you don't have to check for excluded values twice, but with division often you do. But let's go piece by piece and factor this. First term, we can take a 2 out of both of those. I've got 2 and then x minus 2. On the bottom of this, I can take a 3 out of both of those. That would give me a 3 and then a 2x plus 3. And then on this side, I'm going to keep my divide for a minute. 2 can't do anything, so I'm going to leave that as just 2. And on the bottom, this is going to factor into x plus 3 and x minus 3. That's a difference of 2 squares, so we're always going to have the same factoring pattern. And I have a feeling this is going to be one of the ones that I didn't do the math right in my head, and something's not going to cancel out that I was planning on canceling out, which is okay. Okay, let's find some excluded values. 2x plus 3 cannot be 0. That means that negative 3 cannot be 2x, and that x cannot be negative 3 over 2. Next up, we've got x plus 3 cannot be 0, which means that x cannot be negative 3. And then finally, we've got x minus 3 cannot be 0, and x cannot be positive 3. All right, now I've got to deal with the divide. I know that I keep the first part the same, so 2 over x minus 2 over 3 times 2x plus 3. Change this to a multiplication, then we're going to make this the reciprocal. We get 2 on the bottom, and we get x plus 3 and x minus 3. cancel out my 2's. That's the only thing in this problem that can cancel out, because I was planning to do some other stuff, and then I think I just made that a 6 instead of a 3, but that's okay. So our final answer is actually going to be x minus 2 times x plus 3 times x minus 3, and then on the bottom, 3 and 2x plus 3. Nothing else to cancel. That's it. Finally, for this section, we're going to look at a multiplication problem, starting exactly the same way with some factoring. And the first part is going to factor into x minus 2 and x minus 3, things that multiply to 6 and add up to negative 5. For the bottom part, both of these have an x in it. That's x and x minus 1. For the next part, nothing factors there. And then I can take a 3 out of both of those, so 3 times x minus 2. Okay, excluded values next before I start canceling. And I've got x cannot equal 0. I'm going to have x cannot equal 1, and I'm going to have x cannot equal 2. I don't need to deal with 3 because that's a number, and 3 can never be 0, so there's no reason to include something regarding that. Okay, finally doing some canceling. I've got an x minus 2 on the top and the bottom. Those go away. I've also got an x on the top and the bottom. Those go away as well. And we're left with x minus 3 times 2 on top. You can put that 2 out front if you want. And the bottom we got x minus 1 times 3.